Okay, so we're going to step it up a notch. Um, this is quite an interesting one here. It looks like a nightmare to you guys, I'm sure. Again, though, remember what we talked about in the previous lessons. It's all about simplifying those radicals that are irrational and getting them as small as you possibly can. Okay, let's start with we'll do 50 separately, and we'll do 8 just in case it needs to be done. It probably does, in fact, need to be done when you look at it because you can definitely pull another 2 out of it. But let's start with the square root of 50. All right, let's do a factor tree real quick. This is 5 times 10, and this is 5 times 2. A pair of 5s come out nicely. So that's going to be, let's start our equals to here. And this is actually 3 times 5 to begin with. So 3 times 5 is 15. And that 3, of course, comes from the beginning here. 3 times 5 is 15 times the root of 2. That's the first thing we got. Okay, so that is added to um, 4 times whatever we get out of the root 8. And of course, that 4 is going to change as well because that's going to multiply into it as well. But root 8, um, I like to do 8 really quickly because I know that 8 is actually a cube root. So I'm just going to do the three twos. 2 times 2 times 2 is 8. It's a very, very easy one to do. So get used to kind of taking shortcuts like that. A pair of 2's pulls out the 2, and the root 2 goes back inside. I'm sure you're seeing the pattern here. This 2 times the 4 is 8 times the root of 2. Okay, so we're almost through. This is wonderful. And you can see the pattern arising already. I'm sure 98 is going to give us something very similar. I'm going to do the square root of 98 over here. So the square root of 98, our factor tree. This, of course, is going to be 2 times 49. And 49 is, of course, 7 times 7. Pair of 7's. Let's pull out the 7. That's just going to be 7 times the root of 2. Okay, so we're still not quite done. We have to do the addition before we do the division here. Remember that they're really the fraction line is almost acts like parentheses, if you remember rightly. So we do need to do the top first before we do that division. So 15 plus 8 is, of course, 23. So in the numerator, we have 23 root 2. And in the denominator, we have 7 root 2. These 2's can cancel out. So let's just go ahead and cancel out these 2's, and we're left with 23 over 7. And that's quite a nice small solution then for what a big problem we started with. Okay, so this next problem is, I would almost say, actually rather slightly more challenging just because of what it actually looks like. Probably the easiest way is to use distribution. Note that if we looked at this in terms of algebraic terms, because it might actually be simpler to do so, we can actually let a equal the root of 5, and let b equal the root of 6. And if we do that, that's going to make this look a lot simpler for us, and probably something that we can handle a little bit better just for starters. Okay, so we've actually got a and a b, and a and a b, and a plus b and an a minus b. Okay, remember your distribution rules, right? Remember how you got to multiply this a times this b, and then multiply this b times this a, and this b times this b. Remember that? Okay, that's exactly what we're actually doing here. Okay, and just to clarify, this negative, of course, belongs to the b, and this positive here belongs to the b as well. Okay, so we're going to highlight those in blue as well. So let's start with our a terms. A times a This a times a here is a squared, right? A times negative b is negative ab. Okay? Now this positive, I'm going to just highlight those in black to show they're done. This positive b times a, of course, is plus a b. Even though it's b times a, we're going to write it as ab because it doesn't matter which order you do, and I prefer doing alphabetical order. And then this positive b times negative b is, of course, negative b squared. Right, now, those of you who are really observant will take a look at this middle part and notice, oh, negative ab plus ab, don't they cancel out? Well, yes, of course they do. All right, so you're left here with a squared minus b squared. Right, so let's put this part here back into what we'd actually assigned them to be. Okay, so we actually have the square root of 5 squared minus the square root of 6 squared. All right, that's nice. This square root cancels out with the square. This square root cancels out with the square. So I'm left with 5 minus 6, which of course is equal to negative 1. What an elegant problem. Okay, so this is the next problem that's coming up for me. Again, just to remember that it's always beneficial in these problems to do a factor tree and simplify all those terms. One thing that I am going to point out is that this here in the denominator, is a multiplication problem. So that's really the square root of 15 times the square root of 10, which, remember, is in fact the square root of 150. But that's a side note. That's just something that I would like to kind of point out. So they're going to actually end up coming together in the end. So what I'm going to do here is I'm just going to point out that square root of 150 here at the beginning, right? That square root of 150. And I'm going to say, well, that has already been broken out into the square root of 15 and the square root of 10. So we're going to build our factor trees out of this. Okay, we're going to build this 15 separately from this 10. Okay, the square root of 15, 5 is prime, and 3 is prime. So I have nothing else to do. And the square root of 10, 5 is prime, and 2 is prime. So there's nothing else to do there. Okay, so remember that these two 5s come together, right? And I have the square root. I have for the denominator. Let me just write it out for a second. I have the square root of 5 times the square root of 3 times the square root of 2. Now, there is a very good reason why I'm not going to put this back in as a 6. You totally could. You could put this back in as a 6. But why would you want to when you notice that these two 2's can cancel out? Okay, so you end up with 1 on the top instead. The 1 you don't even show on the bottom. You now have 1 over 5 root 3.